if multiple readers are trying to access some value, those readers should be allowed to access that value, but only single writer should be able to update the value. For example, let's say hi all, this is me Karan. So in this particular lecture we are going to talk about different type of mutexes in C++ and their properties. So through this particular lecture you will get to know in what kind of cases we should use some particular mutex and in what kind of cases we should not use some particular mutex. So those kind of things you will get to understand. So I'll highly recommend you to make notes of this particular lecture for a better understanding of this entire topic. So let's start the discussion. So basically there are mainly 6 or 7 types of mutexes. First one is like normal mutex, second one is like recursive mutex, timed mutex, recursive timed, and shared, and the last one is shared timed mutex. And all these mutexes have different properties. So let's try to understand each of them one by one. So first let's talk about normal mutex. So let's say this is a function 1, and inside this function I am using mutex. Let's say I am calling this as a let's say std mutex mtx, and I am locking this particular mutex mtx dot lock. So this is the most simple type of mutex. So in this case what will happen is whichever thread is executing this particular function, that thread will lock this particular mutex, and after completion of the task this particular thread will release the mutex. So let's say this task was executing by thread T1. Let's say if thread T1 has logged this particular mutex mtx and it again tries to lock the mutex without unlocking it. So overall idea is T1 is trying to recursively lock this particular mutex. So in that case this particular operation will fail. So we cannot recursively lock mtx using the same thread. So it should not happen that let's say you are locking mtx.lock and then you are again calling function 1. So this is not allowed. In this case we are not aware of how our system is gonna behave. So this particular behavior is undefined. So what is happening is T1 is trying to access function 1, and as part of accessing function 1 it is trying to lock mutex, and then again it is trying to execute function 1, and then again it is trying to lock the same mutex which is already owned by this particular thread T1. So this particular behavior is undefined, that is we cannot lock mutex recursively. And the second is recursive mutex. So in case of recursive mutex, one particular thread can lock the same mutex multiple times. So let's say now I am taking std recursive mutex mtx. So now I can lock this particular mutex using same thread multiple times. So using recursive mutex I can call this function 1 recursively, and when I'll lock this particular mutex multiple times, so our system or the implementation of recursive mutex will make sure that if I have locked this particular mutex k number of times, then when mtx.unlock will happen, so this mutex will get released k number of times itself. So this is the overall idea behind recursive mutex. Now if I talk about timed mutex, so let's say now I have made this particular mtx as timed mutex. So in case of normal mutex, what was happening was, if this mutex is not available for locking, then thread T1 will keep on waiting at this particular point. But using timed mutex, I can provide the timeout that if I am unable to lock this particular mutex for, let's say, 5 seconds, then this locking will fail and my system will be able to execute the task. That is, this particular thread T1 will be able to perform its operation without even locking the mutex. So timed mutex is generally used in latency sensitive applications where we want to make sure that T1 is not blocked for forever. So this is the overall idea behind timed mutex. Now if I talk about recursive timed mutex, then this timed mutex cannot be logged multiple times by same thread. So let's say if T1 is trying to lock this particular timed mutex again and again, then that operation will fail, or T1 will keep on waiting at this particular point. But if I'm using recursive timed mutex, then I'll be able to recursively lock this particular mutex mtx, and my system will make sure that when I'll release the mutex at that time, if I have locked the mutex k number of times, so I'll also unlock the mutex k number of times itself. So this is the overall idea behind recursive timed mutex. So in case of timed mutex, I'll have some kind of timeout, but I will not be able to lock the mutex recursively. But in case of recursive timed mutex, I'll be able to lock the mutex recursively with timeout functionality. So now if I talk about the shared mutex, so sometimes what happens is, what I want is, I want my system to behave in such a way that if multiple readers are trying to access some value, those readers should be allowed to access that value, but only single writer should be able to update the value. For example, let's say there is this reader 1, this is reader 2, this is reader 3, and all these readers are trying to access some value, let's say x. Then all these readers should be able to read the value, but only single writer should be able to update the value of this particular field x. So in that kind of situation, we use shared mutex. So when reader will try to read the value, it will lock the mutex, but everyone will be able to know that, oh, this particular mutex is locked in the read mode. So the next reader will be able to again lock this particular shared mutex. But let's say the mutex is locked by writer, then next writer won't be able to lock this particular mutex because this is locked in the write mode, not in the read mode. So whenever we want multiple readers to read the value and only single writer to update the value, at that time we generally use shared mutex. And the last one is shared timed mutex. So in case of shared mutex, there is no timeout kind of functionality. So if someone wants to acquire this particular mutex, and if mutex is not available, then timeout will not happen, and that particular thread will keep on waiting for forever. But in case of shared timed mutex, multiple readers will be able to lock the mutex, but only single writer will be able to lock the mutex, and at the same time, if any of them is unable to get the mutex within a certain time limit, then timeout kind of situation will happen and all the threads will be able to execute their operation. So basically infinite waiting will not be there in case of shared timed mutex. So these are the different type of mutexes which we use in different kind of cases. I hope this particular lecture was helpful for you. So let's meet in the next lecture where we'll try to understand some other topic. Thank you.